Hello boys and girls. In this video and the next one we're going to talk about hash functions and in particular secure hash algorithms. This video will show you how you can basically generate these ugly strings that you might know from for example crypto wallets or hashes on GitHub. How these come about, and then I'm going to show you a short script where I implement the use of such a hash function in a Neo smart contract. And in a separate video we're going to go into a little bit more of the technicalities, and for the non-coders I'm also going to do a hash function by analogy video where we are going to basically use a sort of fake cheap hash function to explain how these random looking strings come about. Okay, let's get into it.
Okay, so I will first just point you to a couple of web resources, Wikipedia pages, if you want to go into some detail. There is this general hash function page, which is quite long, and as a basically subclass of that, you can look at the cryptographic hash functions, which are hash functions with some more properties, and you see always this kind of graphics, and we're going to see this explained by Alexandra in the second video. But here we have these particular standards, this secure hash algorithm standards 0, 1, 2, 3, and we're going to deal with 1, 2 in these two videos. There's a lot of detail you can read up, and actually if we look at the SHA-1 for example, I think we have the implementation, at least in pseudocode, on these Wikipedia pages anyhow, here. So this is really the algorithm on the bit level. We're going to scratch this in the second video, but for now we're just going to look at an online application that actually has an implementation of that. So there's this website passwordgenerator.net, and they have one implementation of this SHA-2, and this 256 if you know these numbers, stands for the bits and bytes, and the longer it is, the more secure it is from a cryptographic perspective. But okay, without going into any details now, hash function really is just, for these simple matters, a map, so an operation that transforms one string to another one. So if I write anything here, let's say hi, right, then it takes this word, let's say, as an input and outputs another kind of long random looking string. And the idea is that for any change I make to the input, let's say HIF, you get another output. And if I go here with, I don't know, whenever I click some button and add another letter, you get a completely new output. So hello or Wall Street, right? And you can actually add any kind of information here. You can print a Bible here, and then you would get some output from that. And the function that maps this string to that is some particular implementation, and there are many hash functions, and this is just one particular, also often used in everything blockchain, What you can also do is you take this kind of output and put it as an input, and basically just apply this two times, right? And you can chain this together, make it even more like spaghettified, complicated. You can also, like, if I were to say some sentence, I don't know, I am hungry. I can do I, take this input, right, M, and then add this input that I just got to get another one. Right, and get this another hash out of this. And in this way, I get a kind of chain of hashes, right? So I actually have another video called Blockchain by Analogy, where I explain how blockchain works. And there you see the use of this kind of hash function as well.
Okay, so at this point you might wonder, I mean, unless you already know hash functions, what these kind of operations on the strings are good for, right? So we have seen you take some input and it can be just a word, hello or whatever. It can also be a whole book if you want, you know, if you consider the whole book of Hamlet a long string, you can put it to the hash function and it will return you some small random looking string of characters and numbers. And so here I want to try to explain why this might be useful, for example. So imagine you are on the web in some web forum which doesn't have any private messaging, but it's just one chat room with thousands of people and they all talk with each other. And you, I don't know, you need a cooking recipe for the wedding of your brother. Tomorrow he has his wedding and you want to desperately make a perfect cake and make it a perfect day for your brother and your sister-in-law. And so you ask around and there's some guy with some username, let's say Joey123, and Joey123 posts a perfect recipe and you cook it and you know, everything goes fine and you're so happy and Joey123 really saved your day. And now you think, well, you know, this guy has done so much for me, I want to reward him, I want to give him 50 euros. So you say to yourself, well, okay, let's make a meeting with Joey tomorrow at the main street of your city. You will meet him and reward him with 50 euros. And so you say, hey, Joey, how about tomorrow at 5 we meet at, I don't know, let's say Cloak Street, right? So it's someplace. And then the issue is that you know, it's some anonymous chat room and there's just some username, and you cannot make this arrangement with this person in a private message. You can only publicly invite him. And what could happen now is that any of the other 1,000 users in this public chat room, they could think to themselves, well, okay, so the person who bakes the cake, he doesn't actually know Joey123, and so tomorrow I will just show up at Cloak Street at 6 and pretend I'm Joey123 and just take this 50 euro, right? So if some mean person wants to act as if they were Joey, they could pretend to be them and gain the reward, and if Joey is 3 minutes late then he would not get anything because you were already tricked. So, okay, naturally what you could do is you can say, hey Joey, describe how you look like, and Joey might say, well, you know, I'm this high and I have brown eyes and brown hair and maybe a beard. So you could try to identify a person like that, but I mean, another person might still say, oh, I look also like Joey, so I can still pretend to be him. In any case, what you can also do, and this is where the hash functions come into play here, is to the following. You say, hey, Joey, there are millions of streets in the world. Just choose some street name, but keep it to yourself. I take streets, but you can also say some animal or some plant, right? And choose the street and run it with this secure hash algorithm web app that we just saw. And so Joey might think to himself, well, okay, so let's take a street, let's say Wall Street. And then he would take the word Wall Street, enter it to this web form, and get some hash out of it. And then he would say, hey, okay, Joey, come up with a street name, apply the SHA-256 hash to it, and post in this public forum the result of this hash function. And the point of this would be that now, tomorrow, when you meet with a person, then you can ask the person, okay, so to validate that you're actually the Joey, tell me the street word, the street that you chosen, and I will then with the application compute the hash output. And if it's actually the hash output that you told me yesterday on the web forum, then I know it's actually you. The point is that, there are so many words that you can start from. You can also take some, as I said, some animal or some sensible word, and it will be almost impossible if you make the range of words from which can be taken big enough. It will be impossible for another person to come up with a street name, for example, that will actually map to this hash. I mean, street names is actually not the best example, because actually with a computer you can also run through all the street names in the world. It's probably possible. I don't know how many streets there are, but probably enough, so that the machine is capable. But the point is that if you take just some any sensible expression, and for example the song text of "Hit Me Baby One More Time" from Britney Spears, it will you get out a unique hash, and if we just know the hash, it's impossible to reconstruct which song text or whatever this came from. So in this way, if I next day meet the person and enter a street name and actually the hash comes out that the person gave me yesterday, I know that this is actually the person who I talked to online yesterday, right? Because nobody else could come up with the same hash. Okay, so now that would be one application as a kind of verification, right? And very related to that is, for example, if you have a document like a computer code, for example, right? So this is like a few thousand lines of code. Then you can compute the hash of that. That will also be just some sort string. And if you were to change anything in that computer code and compute then the hash would be something completely different. And in this way, you can actually check if something in a text document, for example, has changed, right? And so if you were to, for example, to make a note, or like say you own people money, right? You have some document with, you own like say 30 people money, and you have the names and the numbers, how much money you own people. Then you can make this list and you can compute the hash of it. And say for some reason you don't store this on your computer, but it's sent on a, like, the university campus computer, and it's publicly accessible for some reason. Instead of remembering what you owned to whom, you can just compute the hash of this text and write down the hash. and then leave it there. And in case somebody, like let's say I owe Alexandra 50 euros, and she decides she wants more money from me, and she actually accesses this text document, and out of this 50 euros she makes 60 euros, so she gets another 10 extra euros. If she were to change the document, the next time I come and compute the hash of this changed document, I would immediately see that it is changed. I don't even have to look at the document. Like, the document could actually be like a huge document. If the hash is something else than it was before, I know that it has been changed. So this is this kind of again, it's another kind of verification. In this case, that nothing changed. And if you go, for example, on GitHub, which uses Git, and the Git software also computes the hashes of changes of code in that same way that I just explained. So you can look on the GitHub webpage, and for each change of the base code you can see it has a unique identifier, and for example, if you release some software, you can also add the hash of the version before it was compiled to a program, and in this way people can verify that they actually have the code that was released by you and not some modified, faulty, malicious code.
Okay, so here we are back to the web application that we saw before. And you know, I mentioned that on GitHub, for example, this is the repository of the City of Zion Neon wallet. Here you also have, as with any repository, the commits, which are the code changes. And if you go on this web page, then you will see that for any change, like, you know, we can take a look at that, and we would see that in this line 4 there was some code added, and all these changes are actually indexed with hash. So you can see here, this is the sequence of changes to the code base, and all these are the beginnings of hashes. And here you can copy this, and you see this is a kind of tower of changes, and all are identified here. And so if we go to the wallet, then there's this releases section. I think now we're at 009. This is the current Neon wallet. And what they do here is also that for each release, they post this hash. So if you don't want to download the executable and use it right away, but if, for example, you want to download the code and compile it yourself, or you download the code from some other web page, right? Then you can make sure that you don't get a you know, malicious fake version of the wallet. Maybe some wallet where somebody hacked some script into the code that sends all funds to himself, right? You can identify the source code actually with this hash. Okay, and for the purpose of Neo smart contract programming, I actually wrote this small script. I give a shout out to Light, the Chinese developer on the Discord, who pointed me in this direction. What I have here is really just the script that I coded in the video on the Neo debugger. So if we scroll down, this is really just what we saw before in this video series, you know, where I explained how to use storage and how to use notify and log and so on. And what I just did here is add one function before the main function. I will shortly go through this function. It's really just a wrapper for the SHA operation that we just saw at the beginning of this video in the website. So, you know, this is a function. I called it apply SHA 265. It takes a string as an input. It returns a string as an output. And what it really does is it just applies this SHA 265 function that is part of this smart contract instance, and the rest is really a wrapper. So I give it an argument message. since this SHA function works only on byte arrays, I have to convert this string to a byte array as far as the C# compiler is concerned anyway. I call this intermediate message bytes. Then I apply the SHA operation, call this hash bytes, and then I turn this back to a string and then return this string, right? And then like on top of the smart contract that you already saw in the debugger video, I added this short if clause. So if the operation is the word hash, then it will just take the second input, which I called key here in the main operation in the last video. I will call this apply function, which will return a string called hash, and then I will just print this log, right? And then I'll return some integer just so that if this contract were to be called, for example, from another contract, then you would know what happened, but ignore this. Really, we're interested in the log, the output here in the interface. Okay, and so now I will step through this contract. So as a default, I was using the print operation, but now I go with the hash operation. And as a key, I will use hello, right? Okay, then debug, then I will step through the code. So I start at main, I go into a hash because this is true because I wrote hash. So he will compute this. He will jump to the right spot to compute the hash here. Okay, does this, and then he comes back, has computed the hash, and then he will write the log. So this is the output, and we can check if this agrees with the website. So you know, I go to this site and I go with hello, hello, and it starts with 2CF, ends with 824, and indeed this is exactly what we expected. You can do another one. Let's go with Wall Street. So B632. Okay, just run this to the end. Okay, so hash and Wall Street, debug, step through this, and right, B6 to exactly what we expected. Okay, then thanks for the attention. I guess I will be explaining some more methods of the smart contract instance in future videos, and I will also use the whole hashing game for the token contract that I will be coding in upcoming videos. Thanks.